AI, machine learning, and data science between them. So, in this video, if we start our discussion with artificial intelligence, so I consider AI as a philosophy to build computer systems or technology as smart as human beings, or maybe more smarter than human beings. And to implement this philosophy, we have different techniques. These techniques can be something like machine learning. Another technique may be game theory. Somebody can try to build a very smart systems with Markov decisions. Someone can play around with factor graphs, complex jargon, different techniques. Maybe combinatorics. Very famous deep learning. So some complex words which may mean something, may not mean something. But basically, AI is a philosophy, and then we have a lot of different techniques to implement that philosophy. Especially machine learning is one of a technique to build systems which are intelligent, which are as intelligent as human beings. And I was always thinking, like, are we in right direction? Like, is it ever going to work? Oh, not me, like everybody was like, okay, they can do face recognition, but is it something that has a potential to build technology as smart as human beings? But especially after this chat GPT, now we can say that we are in right direction, and this is a very potent way to build AI systems. Now, how machine learning works? To understand how machine learning works, we first have to consider, we first have to understand what exactly a programmer do. So a programmer, this guy, makes a program, and once you give an input to this program will give you some result. That's what we do as programmers or software engineers. This is the program. Now, what is a computer program? By definition, a program is nothing but a set of instructions. Sometimes very complicated instructions that a computer can follow. But the core idea is a set of instructions. So if you want to solve a real world problem, then you require a set of instruction which a machine can follow to perfectly solve that real world problem. For example, if we want to find out if a number is prime or not, so we can write a program, we can pass a number is equals to 17, it will say yes, it is prime. But to do that, this gentleman will have to write down a set of instructions which a computer can follow step by step and give us the result. Well, in some way, this method, which we are using and we will use for a very long time, is amazing. But the problem is, what about those problems for which such perfect set of instructions cannot be created? Not because of the human capability only, but because the problems are statistical in nature. They are not well defined. If the problems are not well defined, they may change, or there are so many millions of permutations and combinations involved in it. How can we write down a set of instructions which can perfectly solve a problem which itself is random in nature? For example, let's suppose we want to build a functionality called spam classification. So if an email comes to me, should it go to inbox or should it go to spam? A very basic feature that we all use in different email services. Now suppose this guy want to buy a BMW. Okay, so he want to buy a BMW and he receive an email regarding some 25% discount on BMW. So such an email will be of high interest to this guy because he want to buy a BMW, and if he get a email which is offering some kind of a discount, that is of high importance to us. But this guy have nothing to do with BMW, and he gets a lot of emails related to BMWs, but he don't want to buy a BMW, maybe because he have a better car, he like Tesla, or he don't have money. But every day he get a lot of emails from some dealers saying that we are offering a lot of discount. So one email is of high priority to one user and a spam to another. So email is spam or not spam is dependent on the user profile and user priorities too. It may also be dependent on the content. Or you got $500,000 in lottery which you have never applied, but we are so generous that we want to give it to you. Please give your bank details and we'll transfer this money to you. That kind of email is spam for everyone. So whether it is a spam or not is also dependent on the very text or very content of the email itself. Now you may even get a email from KBC saying that you actually won it. In that case, that's an original email from KBC, but some spammer can send you a fake email from KBC too. So it is also dependent on the network from which the email is coming. Now the content of the email itself is very difficult because you can say the same thing in very different ways, and same words can have different meaning in different context. For example, build a blood bank, rob a bank, or river bank. All three sentences are using the same word, but their meaning is very different depending on the context of the sentence. Or I can say that my name is John, and I ask you a question, what is my name? You can answer it. But I can say the same thing, like my sister have only one brother and his name is John, and what is my name? Still you will be able to get the information. So I can give you same information using different combination of words, and at different places same word can mean differently. So understanding the content of the email is itself a random problem. It involves a lot of randomness, and then user priority and user behavior also change over the period of time. So it's just not possible for us to write a set of instructions that a computer will follow, which is constant all across the time, all across the users, and a general golden program which can answer it. So the way to do it is, can we build a program? Can we come up with a program that can learn this behavior by itself? So it's like we have something called machine learning algorithms. And these learning algorithms, we give them a lot of input like this is the message content, this was the user, this was the network, and we also provide a lot of output. So this was the user, this was the content, this was the network, and this particular email on this date was considered as spam. For some other user, this was the user priority, this was the email, and it was not considered as spam. So we provided a lot of input and output, and somehow this learning algorithm give us something called a model. Consider this model like a program. So here if you see, this gentleman built a program a set of instructions. And once the program is in front of us, you give an input and we will get an output. But there are so many real world business problems where we just cannot write down a program like this. There are so many where we can do, but still there are so many where we cannot. There we use something called learning algorithms, where we provide a lot of data, a lot of input and output. And this learning algorithm gives us something called a model. For now, consider it like it is nothing but a program. Well, it is very, very different. It's not a program, it is a set of numerical operations, but technically they both do the same thing. Once we have the model, we can give it a new input and it will give an output. So this learning algorithm digests data and generates a model. And once we have a model, we no more require this learning algorithm, and it acts exactly as the set of instruction like this, like the program that a user created for us. For example, I write a program y is equals to 3x plus 2. Now, if x is equals to 1, what is y? Somebody can say y is 5. 3 into 1 plus 5, 2. So I have given you the program, you give me the input, I'll give the output. There may be another case where I can say y is 1, x is 1, then y is 2, x is 2, then y is 4, x is 3, then y is 6, x is 4, then y is 8. What is the relationship? Y is equals to 2x. So in a sense, in a very crude sense, I have given you the input and the output, and I've asked you to give me the relationship, give me the model. So that's what machine learning is doing, but at a very larger and much more complex level. Now, when we say that these models are not programs, they are set of numerical operations. So numerical operations require some amount of understanding of mathematics. If you've heard about something called linear combinations, or like if you've heard about matrix multiplications, or if you know some bit of probability, if you heard about Bernoulli trial, tossing a coin, binomial distributions, normal distributions, if you know some amount of calculus, integration, differentiation, high school level mathematics, then understanding of that is a prerequisite to conceptually understand what exactly a model is. But nowadays, with a lot of libraries, machine learning is not that difficult. It's like you don't need to become a mechanical engineer to drive a car. Similarly, you don't need to know all mathematics to build a cool ML system. But yeah, there are differences. Like it's just like driving a car. You can use a lot of Python libraries and can come up with quick and dirty models. But still, the job of mechanical engineer is very different from driving a car. Now, if you see that our learning algorithm basically takes data, and this is algo, this is ML algo, and it gives us a model. Once we have the model, we can deploy it on a web application, we can deploy it on an iOS application, we give it input, it will give us output. But from a very, very crude analogy, consider the example of a car. Just like you don't put crude oil into your car, you just don't put any data into your machine learning algorithm and get any model. So to refine that data to a certain level so that it can give us an accurate, a robust model, we need to understand a lot of data science. So if you see, yes, indeed, we are working on this philosophy. We want to build AI systems. And to build AI systems, we want to use machine learning. But to make our models accurate, we also want to use data science. So they are very different subjects, but still are connected to be a component in our objective of building technology as smarter than or even more smarter than human beings. And now, especially after ChatGPT, things will go crazy, and in next 10 years we will see that technology itself will get transformed, and the way technology will transform the world will also be exponential. So this is a very right time to understand machine learning, artificial intelligence, and data science from a very fundamental mathematical perspective, and that will be the objective of this playlist. And I hope that we together will be able to achieve that great objective. Thank you. Have a nice day. Meet you in the next video.